June 7th, 1940. A warm Friday morning settled over Highland Park, Michigan, but inside Chrysler's executive tower the air felt sharp enough to cut. A telephone on Kaufman Keller's desk rang once, then again. When he lifted the receiver, he expected another routine matter of production schedules or supplier delays. Instead, the voice of William Knudsen, Franklin Roosevelt's newly appointed Tsar of American industrial mobilization, delivered a question so strange that Keller momentarily wondered if he had misheard. Can Chrysler build tanks? There was no sales pitch. No polite let-in. Just the blunt inquiry of a man who had run out of time. Keller leaned back in his chair. He wasn't a timid man, but he wasn't one to bluff either. I honestly don't know, he replied. I've never even laid eyes on a tank. The silence that followed stretched like a taut cable. America was nowhere near ready for the war spreading across Europe. At that precise moment, the U.S. Army possessed 66 medium tanks in total, barely enough to outfit a single regiment. Meanwhile, Hitler's forces were sweeping across the continent with more than 3,000 machines that had crushed Poland in weeks and dismantled France in just over a month. The math was merciless. If war reached American shores, the country's armored strength could be wiped out before lunchtime on any given day. But in those 7 minutes that began with a phone call and ended with an uneasy promise, something shifted beneath the surface of American industry. Neither Knudsen nor Keller could know it yet, but that small conversation would become the ignition spark for one of the largest industrial transformations in human history. Chrysler, a company famous for turning out elegant automobiles, was about to be asked to build weapons as massive as houses and as complex as locomotives, and they had to do it faster than anyone had ever imagined. Not faster by a little, faster by an order of magnitude. As soon as Keller hung up the phone, he summoned two of the sharpest minds in the Chrysler empire. B.E. Hutchinson, chief engineer, and Frank Zeder, vice president of engineering. They arrived within the hour. Keller delivered Knudsen's question word for word. Hutchinson didn't laugh. Zeder didn't flinch, but both men knew the scale of what was being asked. How fast does the Army build tanks now? Hutchinson asked. Zeder pulled out a folder he had prepared earlier. He'd anticipated a question like this, but never expected it to appear so suddenly. Rock Island Arsenal, he said. They hand-build about 3 medium tanks a month. Each one takes 12 weeks. Hutchinson did the math in his head. At that pace, to build 1,000 tanks, he paused. It would take 277 years. Yet that was the Army's demand. 1,000 medium tanks in just 18 months. To Keller, the arithmetic wasn't just bad, it was catastrophic. America couldn't wait centuries. They barely had months. He looked at his engineers. So we don't build them the Army's way, Keller said quietly. We build them our way. It was a declaration that sounded reckless, but history would prove it was the exact dose of recklessness America needed. Within days, Keller, Hutchinson, and Zeder traveled to Rock Island Arsenal in Illinois, the heart of America's pre-war tank program. What they found stunned them. Inside the arsenal, tanks were being built the way master violin makers crafted instruments. Slowly, carefully, and with no two creations exactly the same. Armor plates were shaped by hand. Tracks were fitted by feel and experience. Components required constant filing, adjusting, bending, all because parts were built with tolerances so loose that every tank needed its own personality. This wasn't manufacturing, it was sculpting. A process that could never scale. Keller watched a worker fit an armor plate by tapping it into place with a mallet, stopping, checking, tapping again. It might have been impressive craftsmanship, but to a Detroit automan, it was a nightmare. You can't train 1,000 men to do this, Keller whispered to Hutchinson. Not in a year, not in 5. When the trio returned to Michigan, they didn't bring back a blueprint. They brought back a conviction. If Chrysler built tanks like the government did, America would lose the war before it began. So they assembled a covert task force, a group of thinkers who would soon call themselves the Tank Committee. They weren't military men. They weren't weapons experts. They were automobile engineers, tool designers, metallurgists, logistics minds. People who solved impossible problems with grease under their fingernails and blueprints stacked to the ceiling. And their mission was simple: reinvent tank production from the ground up. The tank committee met for the first time in a cramped conference room at Chrysler's Highland Park complex. The room had no sign on the door, no official designation. It was simply where the impossible would be taken apart and put back together again. At the head of the long table sat Owen Skelton, Chrysler's chief production engineer, a quiet, methodical man whose mind could turn manufacturing into pure mathematics. Around him gathered specialists in every discipline: tooling experts, metallurgists, layout designers, and logistics coordinators. Their first task was simple to state and impossible to solve. How do you mass-produce a machine that has never been mass-produced? For days they circled the question. They sketched diagrams, studied Army specifications, and tore apart blueprints of the M2A1 medium tank. Every meeting ran late into the night. Cigarette smoke hung in the air like fog, and stacks of coffee cups multiplied in corners. The breakthrough came not from thinking harder, but from thinking differently. Skelton, who had remained mostly silent through the earlier meetings, finally broke the quiet. "We're asking the wrong question," he said. Heads turned. What if a tank isn't a special machine? What if it's just a big automobile? The room went still. Skelton continued. "A car is 5,000 parts. We make 3,000 of them a day. A tank is 8,000 parts. Heavier steel, bigger shapes. The math is different, but the process doesn't have to be." It was a heresy in military thinking. Tanks were sacred. Tanks were complex. Tanks demanded craftsmanship. But Skelton wasn't bound by military tradition. He believed in assembly lines, interchangeable parts, and specialization. The gospel of the American auto industry. And for the first time, the committee realized that the Army's way of building tanks wasn't the only way. It wasn't even the best way. As the committee dissected the M2A1, they discovered something shocking. Nearly 60% of production time was spent forcing parts to fit. Armor plates varied in size. Mounting points were misaligned. Transmission housings had to be hammered and filed into place. No two holes were identical. It wasn't incompetence. It was tradition. Arsenals had always built tanks this way. Hutchinson set his coffee cup down with finality. Then we changed the tradition. His proposal was radical. Build every tank component the way automobile parts were made, to tight, precise tolerances. No hand fitting. No last-minute adjustments. No craftsman judgment. Parts should fit because the numbers said they would. Military engineers, when they heard this later, would nearly erupt. Tank parts faced enormous stress. High-precision machining had never been done at this scale. Manufacturing tolerances this tight would require new tools, new inspection methods, new everything. But it was the only way to reach volume. If a craftsman-built tank required 500 man-hours of assembly, a precision-manufactured tank might require 150. A committee member asked the question lingering in everyone's minds. Can we really produce tank armor and drive components with the same precision as car parts? Skelton answered with a dry smile. We won't know until we try. Detroit was full of tools capable of chasing tolerances the old arsenals wouldn't even attempt. Dial indicators, automatic boring machines, milling centers, jigs, fixtures, gauges. The Army had never used them for tanks. Chrysler would use them for everything. The next idea emerged naturally from the first. If we're building tanks with precise components, Hutchinson said, why keep the tank still while we assemble it? Automobiles moved down assembly lines. Workers stayed in place. Tasks were broken into small, repeatable steps. No nation had ever attempted this with tanks. Skelton tapped a pencil against his notes. A stationary vehicle demands artists, he said. A moving line demands discipline, and discipline is scalable. From that moment, the team envisioned a tank factory nothing like Rock Island Arsenal. They pictured a quarter-mile-long assembly line tanks riding on carriers through a sunken trench workers. Stationed along both sides, precise steps, executed in precise order, major components arriving exactly. When needed, holes welded in jigs. Instead of hand-fitted turrets, cast or welded two standardized ring suspensions assembled on sublines engines. Delivered as complete modules, it was the industrial equivalent of rewriting the rules of war. By November 1940, their vision had a name: the Chrysler method. They presented it to the Army. The reception was cold. Military engineers objected to nearly everything: automotive tolerances, too fragile; moving assembly lines, too chaotic; welded armor, too experimental; 10 tanks per day, impossible. But then Keller spoke the only words that mattered. You need 1,000 tanks in 18 months. We're the only ones who can give them to you. There was no rebuttal. Soon afterward, the Army awarded Chrysler a contract unlike any in its history. Build a factory for the sole purpose of producing tanks, and do it immediately. The Army's approval came with one condition: a name. A single man who would design the new facility: Albert Kahn. To the general public, Kahn was an architect. To industry, he was something closer to a legend. He had redesigned how factories were made: strange, towering structures of glass, steel, and reinforced concrete that looked less like buildings and more like industrial organisms. Ford's Highland Park plant, the River Rouge complex, nearly 1/5 of all industrial factories built in America, all carried Kahn's fingerprints. By 1940, he was 71, a German-born Jewish immigrant who had never attended formal architecture school. What he understood instead was something more valuable. A factory was a machine, and its walls were simply the casing. When Keller approached Kahn with Chrysler's challenge, he didn't soften the blow. "We need a tank factory," Keller said. "The biggest of its kind. Built in months, strong enough to survive bombs, and when the war ends, it must convert back to civilian production." Kahn didn't blink. He accepted the job. He then turned to the 600 engineers and architects at his firm and gave them one directive: "We are going to build the Detroit arsenal." They began immediately. Within weeks, blueprints poured from Kahn's drafting rooms in endless stacks. Each page detailed decisions born from pure wartime practicality. The Detroit arsenal would be 1.25 million square feet under a single roof, one of the largest industrial buildings ever constructed, built of reinforced concrete walls up to 3 feet thick, arranged around a central quarter-mile assembly line, fed by a network of feeder lines, machine shops, and welding bays. Kahn's genius wasn't in scale. He laid out the building like a bloodstream. Raw steel entered at one end. Major components were stamped, cast, welded, machined subassemblies merged, tank hulls moved steadily toward completion, and finished tanks emerged from the far eastern doors. No backtracking. No bottlenecks. No wasted motion. But Kahn added one innovation that startled even Chrysler engineers. He wanted the assembly line lowered into the floor, a trench roughly 4 feet deep. Tank hulls would ride down this sunken path. Workers on both sides could access the undercarriage without pits, scaffolds, or jacks. It was simply efficient. Brilliant. And it would save hundreds of man-hours per tank. On September 9th, 1940, groundbreaking began on 113 acres of farmland in Warren Township, Michigan. Summer hadn't yet ended, but everyone knew the snow was coming. Every hour mattered. Construction crews swarmed the site. Foundations were poured morning, noon, and night. Steel reinforcement skeletons rose like the bones of a titan. Concrete flowed in unbroken streams, but speed came at a price. The building would never be truly finished on schedule. By February 1941, the roof was in place. Windows were missing, walls were incomplete, heating systems weren't T-connected, and lighting was spotty at best. It didn't matter. Keller made a decision that would become Chrysler lore. "We'll build the first tanks inside the unfinished building." The workers entered the half-frozen structure wearing heavy coats and gloves. Their breath fogged the air. Snow drifted through windowless openings. Drills screeched against steel in the bitter cold. A solution arrived in the form of a thunderous machine. A steam locomotive brought inside the factory. Its boiler blasted heat across the workspace, warming the air enough for men to hold tools without their hands going numb. The sight was surreal, a locomotive belching steam amid half-built tanks. But it worked, and the work never stopped. While the factory took shape, the tank committee solved engineering challenges one by one. The transmission, the M2A1 transmission, had been designed for hand assembly, a nightmare for mass production. Chrysler re-engineered it completely. A modular unit now came together on sublines and could be dropped into the tank in one piece. 40 hours of assembly became 4. The suspension, bogie wheels, springs, and arms were standardized and pre-assembled. A process that once took days now took less than 2 hours, with installation requiring 20 minutes. The hull traditional holes were riveted. Slow, fragile, dangerous. Rivets could shear off in combat and become deadly projectiles inside the crew compartment. Chrysler insisted on welded armor, supported by jigs that set every plate at perfect angles. The Army protested. Chrysler proved them wrong with ballistic tests. The welds held, stronger than rivets, and much, much faster. By March 1941, components for the first tank were complete. The factory wasn't, but the tank didn't care. On April 12, 1941, Easter weekend, the first Chrysler-built M3 medium tank sat on the assembly line floor of a building still missing walls. It was 28 tons of steel, a 75 millimeters. Hull-mounted gun, a 37 millimeters turret gun, outdated by design yet absolutely critical to America's future. 12 days later, the tank rolled out before an audience of Army officials, Chrysler engineers, local leaders, and factory workers who'd endured a winter that felt like a siege. Keller rode inside as the tank burst into the spring sunlight. The demonstration that followed was theater with a purpose. The M3 roared across the proving ground, smashed through barriers, churned earth into clouds, and fired its guns. A mock farmhouse was flattened beneath its treads. It wasn't subtle. It wasn't elegant. It didn't need to be. What mattered wasn't the single tank on display. What mattered was the system behind it. The line was moving. Workers were trained. Suppliers were coming online. Machines were humming to life. America had not just built a tank. America had built the capacity to build tanks fast. The M3 that rolled out in April 1941 wasn't an ending. It was the ignition. Now Chrysler had to prove the machine they'd built could run at speed. In May, production reached 1 tank every 2 days. By June, 1 per day. By July, the line settled into a steady rhythm of 2 per day. But building tanks wasn't the only challenge. Chrysler needed a continent of suppliers to keep the line alive. The supplier gauntlet B.E. Hutchinson took on the job personally. He drove across the Midwest, knocking on doors, standing in machine shops, speaking to foremen, handing out blueprints and impossible deadlines. "We need these parts," he'd say, "to these specifications. In these quantities. On this schedule, can you do it?" Most suppliers hesitated. Chrysler solved their hesitation with something the Army could never offer. Technical support helped purchasing tooling, guaranteed long-term contracts, and the promise of work that would keep entire towns employed piece by piece. The supply chain grew. By the end of 1941, more than 400 companies across 32 states were building parts for Chrysler's tanks. A foundry in Pennsylvania cast final drives. Wisconsin machinists cut track pins. Ohio forges hammered armored plates. America's industrial bloodstream was redirecting itself toward Warren, Michigan. In June 1940, Chrysler had exactly 0 workers who knew how to build tanks. By August 1941, the Detroit Arsenal employed 5,800, most of them learning as they went. Training schools were set up inside the facility. A worker assigned to install transmission mounts would spend 2 full days practicing on fixtures before ever touching a real tank. Hands that once assembled dashboards or checked carburetors now welded armor plates, fitted bogie wheels, and machined turret rings. The learning curve was brutal, but rapid. Soon, each shift developed its own pride, its own momentum, its own competition. Production numbers were posted on bulletin boards daily. Men and women checked them like box scores. Who beat yesterday's record? Who got closest to the goal? The factory floor became a battlefield fought with wrenches, gauges, and sweat. As 1941 wore on, the M3 medium tank reached British forces fighting in North Africa. The British nicknamed it the Grant, after Ulysses S. Grant. They admired its mechanical reliability, decent firepower, respectable armor. But they criticized two things endlessly: its extremely tall profile, the awkward side-mounted main gun that couldn't fully rotate. Chrysler already knew these flaws. From the beginning, the M3 was intended as a stopgap, a bridge, not a destination. The tank committee had been quietly working on its successor for months.